Last time we looked at some of the middleware that ships stock with Express and Connect, and we saw how it made our apps better. It gave us more functionality, prevented us from having to implement things, and it just sort of ran without polluting the actual flow of our application. And that was really wonderful. Well, sometimes you need some functionality that isn't in what ships stock with Express and Connect, and sometimes you don't want it to run on every single request. Well, that's what we're going to talk about today, doing our own custom middleware in Express. A good opening question that we could ask is, what sort of a beast is a middleware? Here we are at the page for the Connect static middleware, and if you scroll down there, you can actually see the source for it. And what we find down when we dig is that this is just a function, but it's a function with 3 parameters. One is a request, one is the response, and one is something called next. With that in mind, then, we could write a simple little middleware function. First of all, let's do a little bit of organization here. These are actually the route handlers. And then down here, we'll add a comment for middlewares. So with that in mind, we're going to create this little function called stupid logger. And we call it that because Connect ships with a better one that's more robust, and we're not going to use this one in production. So with this outer one in place, then we'll return an actual worker here called stupid logger inner. And that will take our 3 parameters. Now the reason that we set it up this way is this outer function here gives us an options parameter which we can pass in, and then those options could affect the behavior of our inner middleware, and we could get back different copies of it with different options. In fact, that's exactly how the static middleware is set up. We can see that the outer function takes our root path and a set of options, and then this is the function that actually does work in the static middleware. So the actual work that we're going to perform with our middleware is to just say where we were called, and that we can do pretty easily with this. And then comes the interesting part. When we're done doing our work, we have to call next, which happens to be a function. What is next doing? To answer that, let's head back up to where we used our middlewares above. Here we have body parser, method override, and static. And when we actually put them into the application this way, what we're really doing is creating sort of a middleware queue that Express is going to run through. So the first middleware that we put in was the body parser, and running that line of code there, what it actually does to our queue is something like this. Our queue would then have the body parser middleware into it. Similarly, calling app use, method override, and static would have the following effect. We can see that all 3 middlewares are now in this queue, and when a request comes in, it comes to the very first one, and this is where next becomes really important. Looking at the code for the body parser middleware, we can see that it really just links together 3 other middlewares through a series of callbacks, culminating in multipart. Let's go have a look at multipart. What does it have? Somewhat of a long middleware, and as we go through it, we see calls sprinkled around to a call to next. Next is what controls the flow from one middleware to another. So body parser comes in, and eventually there's some execution path that's going to call the next that's given to body parser. If body parser didn't call next, the request would just end up hanging right here inside of body parser, and we certainly don't want that to happen. Now, something that we haven't used explicitly is that Express has a router middleware, and there are a couple of different ways you can use that. One is how we did it, which is just to define a route. And at this point, we essentially force Express to inject its routing middleware into the queue. When we hit our first route in our code, Express puts the router middleware by default into there for us. And so now when a request comes in, it goes to body parser, then to method override, then to static, then to router. Now there is a way to have explicit control over when the router gets put into the middleware queue. And we do that by explicitly using the app.use app.router call here. Notice that this middleware doesn't take a function call as do body parser, method override, and static. So as this code is written right now, we can remove those lines and it functions exactly the same. But one little trick that we can do is to put the router above static. In this way, if there were a route that happened to match one of our actual defined routes, then we would hit that before going through static, because static is going to go through the file system to see if the incoming request matches a file. We can speed up our app a little bit this way. Of course, with the middleware is defined in that order now, our middleware queue is going to look like this as opposed to how it did before. Great now, so let's look at how to actually use our stupid logger here. One thing I need to call out is when I originally typed this, I forgot to put the function keyword in front of stupid logger inner. You might have noticed that that just magically appeared in the code as we were looking at other things. My apologies for that. So make sure to put function in there, otherwise it definitely won't run at all. Turning to the Express documentation then, we can find that the first way of specifying which requests a middleware should run on is to use what we call mounted middleware. And to do that, we use app.use and pass it a function, which may look surprisingly exactly like what we've been doing up to this point, because it is. But notice that this function can take an optional first parameter of path. And that path is where the middleware gets mounted. And if you don't supply it, it gets mounted at the root. And do notice that mounted at the root path does not mean only runs on requests that are the root path. Let's have a look at what we mean there. We're finally going to add some middleware in here. So we'll just do an app use, and we'll explicitly call out the root path here just for fun, I guess. And we want to use stupid logger, and we don't need to pass it any options. So we'll just mount it like so. And then we're going to need to spin up our server. And we do that, of course, with the old trusty node server. And there it is running fantastic. We switch over to the browser and you might remember this great graphic from last time. So we come back to our console here and we can see our middleware talking, "Hi, I was called at favicon," but we don't see any reference to our root path. Why is that? Here's a little gotcha. Notice that up here we injected the router into our middleware queue at this point. Well, the trouble is that the router handles the request and the request is then all done. So our middleware here gets ignored. So what we'll need to do, let's just take all these middlewares, let's pull them down here below our functions. And now this flow is going to make a lot more sense. We can take our stupid logger, put it above the router, restart our server, come back to the browser, reload, and now when we come back, we can see that indeed the root path got hit there, and we can also see that there was a call that static was hiding from us because it was handling the request. So notice here that images sort and shield.png didn't match the root path, but it had the slash in it, so stupid logger did get called for it. Basically, the way that this works is it starts walking from left to right, and if you're able to get through the whole mounting location, then it will run the middleware. Now, do really keep this gotcha in your mind, because it can be a source of some really insidious errors that you're just not quite understanding. For example, if we put our router above body parser and method override, then remember when we were doing that put request? Well, guess what? It's not going to get picked up because the routes will have already run before body parser had a chance to determine that the incoming request was a put. It would just have been picked up as a post the way we had coded it before. So order of middleware matters a lot because it is a queue and it just walks through the queue in order. And our queue now, of course, looks something like this. Now we're going to do something a little bit more useful than our stupid logger. We're going to simulate logging in. The reason that I say simulate is that we haven't done database access yet, so we don't actually have a way of storing user information. But we're going to sort of fake it right now to show how that would actually be structured and how middleware makes that a lot easier to deal with. The first thing that we're going to need is a connect middleware called cookie session. You can read about cookie session here. And to use it, you just plunk it into the list of middlewares with its friend, cookie parser. Cookie parser is responsible for taking the incoming cookie header and presenting that to you in a useful property of the request object. And cookie session handles using a cookie to create a nice session variable. It takes the secret, which is used to encode the cookie, and this is not a particularly secure one. I don't recommend using it in production. And then the session here is what that's going to look like in your browser, what the name of that cookie will be. So the first thing that we need to do here is whisk some markup into it. And we'll just spare you the agony of seeing that get typed. But the important thing to notice is that we're going to post to this form action login. We, of course, need to define login. So let's go ahead and do that. And now here's where we're going to get to use our session cookie. And we use the cookie like so. First of all, if you remember, body parser is going to turn our username member on the form into a property of the body object that is a property of the request. So we want to make sure that the user supplied one. If the user didn't, the user gets redirected back to the home page. If there is a username, then we can just put that in our session. Now, this rec.session object is provided to us by the cookie session middleware. It allows us to use the session object and to assign values to it, and it will then take care of turning that into a proper cookie response that the browser will get. Similarly, we can also retrieve values from the session cookie in the exact same way. So if the user did give us a username, we'll take that username, put it in the session, and then issue a redirect to the adventures page to begin the excitement. One last bit of bookkeeping, we do need to wire the route up as well, and we do so just by calling app post with the appropriate arguments. Now let's be sure to restart our server. We head back to our browser, and we can see that the form is here in place, and my name is Ethan, so I'm going to type in Ethan to start eAdventures, and here we are at the adventure screen. Now let's take advantage of our cookie object here. We're going to personalize the adventure screen by coming in here and injecting the username that we got. Like so. And then we restart the server. And this time when we log in, we can see that our username is present on the screen. Hooray! Now that's all well and good, but what would happen if we cleared the browsing data, effectively logging ourselves out, and then reloaded the page? Uh-oh. Hopefully someone didn't log in with that as a username, but obviously this is not quite right. And it's going to be middleware to the rescue for us. We define a function called ensure authenticated. It takes the request, the response, and next, and then we just check to see if there's a username on our session. If there is, we call next to proceed. If there isn't, we call res redirect, which will close the request for us because this sends a response to the browser, hey, you need to go to this path instead. The question now becomes, how do we get this to run in the right places? We don't want to run it on the root, so we don't really want to use app use ensure authenticated. That's not going to be right. So how could we actually get it on there? We have a couple of different options. These calls to like app.get, app.post, these can take more than 2 arguments. For example, we could just put another function here, ensure authenticated. And what's going to happen is when we get to get adventures, it's going to walk down this chain. So let's go ahead and restart our server and see that in action. We see it sent us back to the home page. Why is that? Again, it walked down the functions in order, and the first one it found was ensure authenticated. It checked for the username, didn't find it, so sent us back to the home page. To use that method, we'd have to basically copy this and put it into each route all the way on down. That's kind of tedious. We don't really want to do that. Well, here's the next option. We can do something like this. Now what that's going to do, it's kind of like a mount point again, but we get some finer grained control of where it occurs. If we hit the root path, this home answer is going to actually service the request and close it out, so we're not going to fall through. But if we hit any other path, it will hit our middleware, but since our middleware doesn't close the request unless the user isn't logged in, then it's going to execute our middleware and then just keep right on going. But as always, let's check the gotcha here. Our login won't work either because ensure authenticated will close the request before we get to login. So we'll need to pull that out and move it up here. Let's restart our server. And now when we load the home page, it loads just fine. Then I can log in, and here I am back at the adventures page. Ooh, but there's one more surprise here. Notice that when we do the call to ensure authenticated, we specify get. So this is actually going to work only on a get. So if I were to try to post to adventures without a username, it would work just fine. And that doesn't break our current app, but obviously that would be a real problem if it were actually doing anything with persistent data. To fix that, we can just simply go app.all. Now, no matter what the HTTP verb, we will run the ensure authenticated middleware. Just for good measure, let's have another graphical look at our middleware Q. This is the way we've defined all of our middlewares, and we've injected the router into this point in the stack. Now the router then walks down its own queue, starting with the get at home that we have and the post for login and the ensure authenticated. And this is why our request to home, even though it matched the same path as ensure authenticated, worked, because home intercepts it, closes out the request, and then we don't even keep walking down. Two more quick things and then we'll be done with our exploration of middleware here. First is, let's consider how to handle 404 errors. Here we have a route handler. This one's not a middleware because it doesn't have next, and it's just called not found, and it gives us a nice little page. Let's consider how we would then use that. We mount it at the very end at the root path, and there are a couple of things to consider here that are pretty important. First of all, we didn't put it in as a route because we wouldn't want the 404 to interfere with any of our static files. So let's go ahead and restart the server. Head over to the browser, and then we'll just put in some gibberish, and notice that we get our nice 404 page. For our last magic trick, let's have a look at error middlewares. Here I've pasted in two functions. They both have an arity of 4. Notice they start with err, which is an error object, and they take rec, res, and next, just like other middlewares. That whole 4 parameter thing, that's a really big deal. And I did 2 of them here to show a point. The first one here is called catch errors, and it just gives us a notice that there was an error message. And in a production application, this might be a good time to email the engineers and say, hey, there are problems happening on the server. Notice then that it just calls next, passing in the error that it got. It just forwards it onto the next one in the chain, which we're going to wire up as the show error page, which would give the user a good message, although we did sort of reuse the one before. So let's just give that a slightly better thing here. Better is, of course, loosely used. The next thing that we want to do is actually wire these up. So we would do that just as you might expect. We restart our server. Actually, we need to define a route that will give us an error first. So we'll drop one in here real quick. Now notice this is designed to be a request handler, even though it has the next. Request handlers can have next. We're just going to use it though to inject an error into the flow of our routes and middleware by calling next and passing it a new error object. And then we're going to put that in as a route off the root at read from DB. And once we do that, save the file, restart the server, we'll head over to our browser and put in our path, and we see it's a 500 error. And then down here in our notice, we can see that our error handler got called. The show error page, sorry, that's not from show error page. That one is from catch errors. And there we might, again, put in an email to the development staff. Maybe that goes to our auto bug tracker or something. And then we have the error handler that actually shows the 500 page. And we have those separated out for some nice clean logic. You can do that. You can have more than one error handling middleware. You can catch different kinds of errors in different ones by branching off of whatever your error object is, and so forth. Wow, so that was a pretty good dive into custom middlewares in Express and seeing how the order that we declare them matters, and also seeing how the order of routes matters. If you've made it this far, give yourself a pat on the back. You've probably noticed how our single file application here is getting really out of hand. We really need to look at a way to break this up into multiple files, and that's exactly what we're going to do next time. We're going to dive more into require, how it works, where it looks for things, how we can define our own, and so forth. So hope to see you next time, and until then, happy coding. If you found this episode useful, or if it saved you some time, would you consider spreading the word by either sharing it on Facebook, tweeting it, or even just linking to it from elsewhere on the interwebs? Thanks a bunch.